with that discussion in our head, let's now write our simple definition of the electric potential. Okay, electric potential. So it is a scalar field. And let me stop there and tell you how happy you should be it's a scalar field. Okay? So when we, in this class, so we've done now 3 learning sequences. We're on the 4th learning sequence. So in the on-campus class, that's basically a learning sequence per week. So I tell the students in the first 3 weeks, we're going to hit them with a lot of math the first 3 weeks. The very first week is all vectors. You've got to be really good at vectors. The second week, we set up integrals. You've got to be able to be very good at setting up integrals and solving them. And the third week, we do vector calculus already. So sometimes by the end of the third week, students that are really struggling in math are very depressed, and they don't think they're going to make it. So I'm here to tell you that's it for a while. Okay? We've done all the new math. If you're kind of hanging in there with all that stuff, now we get to just use it. Okay? We're not going to introduce a new math concept every learning sequence every week. We're kind of done. For instance, now we're taking a step back. It's a scalar field. It's not a vector field. So it's actually a little bit easier to use than the E field. It's just, it makes sense electrostatically to bring it in later. But it's actually mathematically simpler because there's no direction to worry about. It is just a simple scalar field. So if you're feeling lost in the math and you're thinking of giving up, don't give up. This is not the time because the math is about to calm down. Okay? So it is a scalar field that is equal to the electrostatic potential energy So that's what we were talking about when we thought about the test charge being close to the big charge or far from the big charge, the difference in potential energy. It's not the same as the potential. It's the potential energy. And we'll be calculating it and talking about it in more detail. Per unit charge. This is what makes it special. Per unit charge. This is how it's analogous to the electric field. The electric field is the force per unit charge. This is the energy per unit charge. Here's the confusing part. Relative to some point where it is defined to be 0. Which is usually far away. This definition is getting a little bit not too technical. Usually far, far away. But in this galaxy. Okay? That's about as simple as I can get it to bring all the points in. Okay? Scalar field, good news. It's energy per unit charge. You got that idea. This relative part is tricky because a lot of times when we talk about the potential, we might call it delta V. We'll be calling it that soon, because that indicates it really is a change. But sometimes we get lazy and we just call it V, which indicates maybe it's not a change. So you got to keep up with, is it an absolute number? Is it a change? What's the deal? So we'll be talking about that quite a bit.